So here is the second example involving vertical circular motion. A ball of mass m is attached to a string of length L meters, which lies in a vertical plane. It is struck with a speed of v meters per second horizontally. If the particle just about makes it over the top of the circle, show that firstly the initial velocity is root 5gl meters per second, and secondly the tension is 3 mg newtons when the string makes an angle of 90 degrees with the horizontal. So you will have to know a few trig ratios for this, so go ahead and try this problem, and when you're ready come back for the solution. So one thing that actually has to be made clear is that the velocity of the particle at the top is not zero. If the particle and the string remained contacted throughout and it reaches zero here, it will actually follow projectile motion until it becomes taut again. So it would actually take a path like this before coming taut and then going back and doing the loop again. So the velocity at the top is v. So firstly, the centripetal force equals mv squared over r. So T minus mg cos theta is mv squared over L. So the tension is mv squared over L plus mg cos theta. And then at the top, theta is 180 degrees, and the tension is also zero at that point. So the tension goes, so we get mg, adding mg to both sides, equals mv squared over L, which means that the velocity of the particle at the top is root gl meters per second. Now with the conservation of mechanical energy, we get mg by 0 because it starts at the bottom, so half mu squared, which we're trying to find, equals mg by 2l because we have the center here is L away, and so the center from this side is also L away, which means that this height is twice L, plus a half m by v squared, which we found is root gl. So we get a half u squared equals 2gl plus a half gl, multiplying by 2 and taking the square root, we get that the initial speed u equals the square root of 5gl. Should be meters per second. Now, of course, 5g is 49, so you could actually write this u as 7 root l meters per second. But we'd like to keep the g in wherever possible. So for the second part, we know the general equation of the tension is mv squared over L plus mg cos theta. So at 90 degrees cos 90 is 0, so our first equation is mv squared equals TL, this guy right here. Then the principal conservation of mechanical energy, we know that our new initial speed is root 5gl, and after 90 degrees, so after 90, whoops, get the pen out. So after 90 degrees, it's at a height of L. So we get that 5mgl, so after multiplying by 2, 5mgl minus 2mgl is mv squared, so mv squared is 3mgl. So we have our mv squared equivalents, so all we need to do is cancel the l's, and we do indeed get the tension in the string 90 degrees is 3 mg newtons.